These are shape-changing aircraft to affect flight control, but rather they change the shape of their wings to affect flight control. The original flight, the Wright brothers flight, didn't have conventional flaps. It had a wing twist phenomena. So the wings were very lightweight and they twisted them to get flight control. So that, you could say, would be the original motivation or the original morphing effort. Is it moving? There we go. What we're doing now is really based on and motivated by watching birds and how they fly. If you look at a bird, it has maybe 100 feathers along its wingspan, and it'll move 3 or 4 of them together as one muscle. And so it can make one go up and one go down. So it can create sort of a serpentine shape along the profile of its wing. We can't do that with any aircraft, but we can do that with this material. So this is a original version. The thing that makes this contouring possible is a thing called a macrofiber composite actuator. Big word. It's basically a piezoelectric composite. That means that the structure and the actuation device are all one thing. So there's no mechanism like there is in a traditional airplane. So that means it's potentially lighter, and it can do these unusual maneuvers that a bird can do. The material, which was invented in 2000, allows us to do things that we couldn't do with traditional materials because it's an active material, which means it changes its shape according to an electrical input. People don't like to think high voltage in an aircraft. One of my students figured out a nice lightweight, compact DC-DC conversion device to change the high voltage need to a low voltage need. And the current was minuscule, so really the power was not bad. So the project now is still sort of in the developing stages where we've built some prototypes, which is a long process. You build some and throw them away. Build new ones, try again. Tested them in a wind tunnel. In the future, I expect this technology to be limited to unmanned aerial vehicles. The FAA is a huge force. It's a good force, but it puts so many roadblocks in terms of new technologies on aircraft that I think it'll be decades and decades before any type of morphing technology shows up on an actual airplane. One of the questions that comes up in morphing, if the Wright brothers had already thought about having a twisting wing to do flight control, why has every airplane past that time used conventional discrete flaps or control surfaces? And the answer to that is, in order to twist the wing with a reasonable amount of actuation, the wing has to be very lightweight. Being very lightweight and flexible means it flutters very early, which means the plane can't go very fast. Now we can reevaluate that possibility because we have new materials and because the materials themselves that form the structure are actually actuation devices as well. So it's sort of a multifunctional system that allows us to revisit